What is up, everybody? Welcome back to the Mathnasium. Got another exciting video for you today. Today we're going to be going over linear functions and graphing. I'm really excited. But first, I got to tell you about an exciting timeshare opportunity in Azerbaijan. I know that you guys, there's a lot of people trying to smear this timeshare operation we've got going, but I'm going to tell you it is the most relaxing experience, and it's only going to set you back about maybe 10 or 15 years into your retirement. So if you're interested in that, just let me know. So let's get started right into functions. We're going to talk about linear functions. I don't know what comes to mind, but when I was talking to kids today about linear functions and what springs up in their heads, a lot of students said, "Hey, what about this, Mr. Slagle? What about y equals mx plus b?" Does that ring a bell? Well, it should. It should. M, remember, that's your slope. Y-intercept, that's b. B for bingo. I don't know. What makes a linear function so special? Linear function is kind of like what I think about as it's like having a growth that is the same over the same time period that happens over and over again. So, for example, your income, in a lot of ways, from your job should be linear on any given year, unless you get a pay raise halfway through the year. But if you have a fixed income, if you're making $15 an hour, then every hour you work, you're getting $15. It's a predictable growth. It's the same every hour that passes, okay? Linear functions have this pattern of change. In the terms of the income, it's the $15 per hour pay raise, right? So if you're talking about somebody's bank account, that's something that would be really easy to model with a linear function because it's changing. Maybe you have a fixed spending, but it's changing and it's growing over time at basically a fixed amount. Okay? So let's hammer out some of these fine details, and we're going to keep cruising. Slope of a line is a measure of how steep the line is. Lines with positive slope rise, lines with negative slope fall, so forth. Let's change our color. We're going to mix it up here a little bit. So the equation for slope is y2 minus y1 over x2 minus x1. And that's given, if you have any 2 points, we can figure out what the slope is by dividing the difference in the y's divided by the difference in the x's. You guys may have seen this before as rise over run, or change in y over change in x, sometimes written like with triangles. That's delta y, delta x. That means change in y over change in x. So it's important to remember that slope kind of falls into 4 categories. Those 4 categories are when the slope is positive. When the slope is positive, that's when you have a slope that's kind of going uphill like this. It could be really steep. Anytime you go from left to right on the graph and you're going in the upward direction as you read from left to right, this is going to be a positive slope. Another scenario you can find yourself in is obviously negative slope. Any 2 points are either positive, they're negative. We say the slope is negative, which means as you go from left to right, it's going downhill, like so, kind of like that timeshare opportunity. And then there's also a couple other cases. So you could either have going up positive, you can have it sloping negative, and it can be really shallow. There's also such thing in between positive and negative is zero slope. Zero slope is represented by a horizontal line, perfectly horizontal. Now you think about zero slope and why this makes sense. Let's say this is the point 1, 2, and this is the point negative 1, 2. Now if we were to plug these points here into our slope, you'd see that we'll call this y2, y1. When you take the difference here, you end up getting 0 in the numerator. And 0 divided by any number is 0. Now, the other situation arises when it's the opposite. The 0 ends up being in the denominator, which You go to your calculators right now and do any number divided by 0, your calculator should spit back an error. It'll say domain error, or it'll say just error, or maybe undefined. So if your slope, if you have a vertical line, you're trying to calculate the slope, we say that that is undefined slope. And that's because ultimately they have the same x value and you end up dividing by 0 in this equation. But we're going to see some examples here in just a minute. Find the slope of the line through each pair of points. Does the line that passes through these points rise or fall? How can you tell? Now, just looking at this, if you can kind of picture, I always try to picture what my answer is supposed to be, before I am kind of all done here. So let me kind of draw this graph out. Where is 3, 2? So let's go over 3 up 2. It's somewhere right there. And that means negative 9, 6 is higher than 2. So I'm going to go way over here and up a little bit. I can tell that the line that connects these two is going to have a negative slope. Quick sip. I'll make sure to be real quiet on the mic. Oh, perfect. Okay, now let's do the same thing. Let's do the calculation for real. The reason I did this quick little graph is so that we could see and check our answer. We know our answer needs to be negative. So I'm going to start with m equals, boy, that is very straight. I'm going to try and turn my writing tab. There we go. y2 minus y1 over x2 minus x1, that same equation. Now you typically, for the first one I'll do this, it doesn't matter which point you label as point 1 and point 2. So you can go through and you can say, all right, I'm going to call this x1. If this is x1, then this is y1. That is to say, the x coordinate of point 1 and the y coordinate of point 1, which means the negative 9 is x2 and the 6 is y2, the y coordinate of point 2, so on and so forth. So now we can just go over to our equation here and plug things in. I always start by just putting the minus signs, and then it's just a matter of copy and pasting in these little blanks that are left over. So it's going to be 6 minus 2 divided by negative 9 minus 3. And now all we have left to do is simplify. 6 minus 2 is 4. Negative 9 minus 3 is negative 12. And 4 over negative 12 simplifies to negative 1/3. So we've found our slope. And that seems to agree for the most part with that little graph that we did earlier. So it looks like this was negative slope. As we go from left to right, this is decreasing. Okay, the same thing. You guys can try this one on your own. Please feel free to pause the video. I'm going to go over it here shortly. Okay, here we go. Let's change colors. I'm up for a color change. Feeling green right now. I'm feeling kind of green. M equals, again, y2 minus y1 over x2 minus x1. All right, let's do this thing. Minus, that's 2 minus 2. So this 2 minus this 2 over 4. 4 minus negative, which gives us 0 over 6. Is 0. 0 divided by 6 is 0. That we can do. This is, you have 0 pizzas, you're dividing them amongst 6 people. How much pizza does each person get? Well, they get nothing. That makes sense. I find myself in that situation quite often. It's when the zero's on the bottom that it's... All right, let's keep on cruising. Now, you guys are probably pretty familiar with this form. It's pretty famous. If you took anything away from Algebra 1, that's y equals mx plus b, and we kind of stated that at the beginning. Okay, so a line with slope m and y-intercept b has the equation y equals mx plus b. This is our slope. This is our y-intercept, right? It's called slope-intercept because it's the order that it's written. Now, the cool thing about slope-intercept form is if you take any 2 points and write it in slope-intercept form, it's going to be the same for any 2 points that are on that line, whereas other forms kind of can exist in different states. There is one unique slope-intercept form for any line, which is really helpful, and why it's probably the most used form for linear equations and linear functions. All right, so let's recall, how do we graph? First thing we do is we start with the y-intercept, which is right here, 3. 3, the point, or rather 0, 3 is my y-intercept. It is a point. Now, to graph the rest, we follow the slope. So let's identify officially the slope and the y-intercept. Y-intercept, in this case, b is equal to 3, m is equal to 2 over 3, which is just the coefficient of our x term. So here's my y-intercept. My rise in this case is 2, my run is 3. So I can go up 2. Now I know that my slope is positive, so as I go from left to right, it needs to be going uphill, which means when I go up 2, I'm going to go to the right 3. I'm going to repeat that all the way across my graph. It's an expectation for my class that you put these points, that you know that they travel through all the way across your graph. So I can see and you have a straight line. Let's do another one. Okay, start by identifying m and b. M is equal to, b is equal to. Okay, m is whatever the coefficient of x is. This term, that in this case, that's negative 3, and we can write that as a fraction as negative 3 over 1. Okay. And b is whatever we're adding. Well, we're not adding anything, so we can stick on a plus 0 here, right? And b is equal to 0. You don't have to. You just recognize that we're not adding anything, so b is 0, which means it crosses. You always start with the y-intercept first, so it crosses at the origin. Okay, now we have a slope of negative 3. That means when I go from left to right, it should look like it's going downhill. So a lot of people say, I have to go down 3. Well, you don't actually have to. You can go down 3 to get the next point. You could also go up 3. As long as you remember, it needs to slope downhill. So my rise is 3, my run is 1. That's still sloping downhill. And if I go down first, then go over 1, so forth. Back up this way. Great, fantastic. There's our slope. And then I graph this southpaw here. Time for a color change. Maybe not. I'm kind of digging the green. I am digging the green. This is something else, let me tell you. All right, let's go. Next one. All right, now we line up and we say, all right, let's identify M, let's identify B. Wait, hold up. The only reason I could identify M and B here is because it's in slope-intercept form. It says y equals. This one says y equals 2, so we can see M and B. This line is not in slope-intercept form, so I can't see what the slope is, and I can't see what the y-intercept is. But what do we have to do? We have to get it into slope-intercept form, which means we need to solve for this y right here. Well, there's a lot standing in the way. The first thing I do in solving and for slope-intercept form is you want to get the term that has y in it by itself. That means I got to get rid of this 5x. It's currently positive, so when I'm going to subtract it from both sides, like so, treat both sides equally. You'll end up with negative 2y equals minus 5x minus 8. That is one way to deal with this. Okay. And now I want to get y by itself. Y is being multiplied by negative 2, so that tells me I should divide both sides by negative 2, like so. Okay. That is y equals, so negative 2 divided by negative 2 is a 1, coefficient of 1. Negative 5 divided by negative 2 is a positive 5 over 2, and negative 8 divided by negative 2 plus 4. Now that it's in slope-intercept form, is so outstandingly beautiful, I can see my slope is 5 over 2. My y-intercept is 4. Okay, let's go ahead and graph this bad boy. Okay, 4 is my y-intercept. I go up 5. Oh, wait, that's off my graph. I want to know, go down 5, back 2, down 5. Bingo. All, not just the points I drew, but every single point is on this line. That means every single one of these coordinates makes this equation true if you were to plug them in. Let's keep rolling. We're going to talk about another form here called point-slope form. Point slope form is really useful for taking information and turning it into slope-intercept form. The point slope form is as follows. It's y minus y1 equals m times x minus x1. Okay, yeah, so fantastic. What does this mean, and where does it come from? You just pulled this equation out of thin air, and you're supposed to, everyone's supposed to trust me? I don't think so, they say. They say. Okay, what this really comes from is it comes from the equation I already gave you. Now, when you have a linear equation or any function relationship, you have an input variable and you have an output variable. So all that they did, basically, for point slope form is they took the slope equation and they cross-multiplied, right? They used proportional reasoning, cross-multiply. Here, y2 minus y1 times 1 gives us y2 minus y1. Anything times 1 is itself. Then we have m times x2 minus x1. So now, for this equation, they plugged in for y2 and x2. They put the x and y in there for our input and our output of our function, and it created this beautiful equation that allows us to take a starting point and a slope and write the one equation, or turn that into the one equation that represents that line, that unique slope-intercept form. We can alter this point slope form, and that's what we do. If we want to write something in slope-intercept form and we have information like we have 2 points or we have a point and a slope, we always start with point slope, which is y minus y1 equals m times x minus x1. And then we can use the information from that to put our answer in slope-intercept, which is, remember, y equals mx plus b. So we go from this form to this form. Pretty fantastic. All right, so let's practice. I'll do the first one, and then this is asking us to write it in point slope. So we start with y minus y1 equals m times x minus x1. You can't write this enough, apparently. Okay. This right here, this is x1. This is the x value of my point. This is the y value of my point. Okay, so they go into these slots. So all we do is we plug them in. Y minus y1 is y minus -1 equals -1/2 times x minus 8. And we've got everything plugged in, but things can be simplified. We have this double negative, the opposite of -1 is +1. And since the directions did not ask us to write it in slope-intercept form at this point, we are finished. This is my final answer in point slope form. It's beautiful. Okay, you guys try this one. I'm changing colors. Changing colors. Okay, here we go. You're going to do y minus -2 equals 2 times x minus 4, which is simplified y plus 2 equals 2 times minus 4. And it says point slope form. We are done at this point here. All right, our last two problems do not tell us to write it in point slope form. They want us to write it in slope-intercept form. So if we're going to do that, we're going to follow those instructions that were given earlier. Okay, to find the equation of a line in slope-intercept form, you always start with point slope form, move to slope-intercept. There are other ways to do it, but we're just going to keep it simple. I'm going to tell you there's one way, and we're just going to do that way because it's pretty easy anyways. So we have to put it into point slope form, but we don't have the slope, right? We need a point and a slope. We don't have the slope. So step one, if you're given 2 points, step one is to find the slope. M equals y2 minus y1 over x2 minus x1. So let's make this happen. y2 is 2 minus 0 over x2, which is -3 minus 5. So our slope here is 2 over negative 8, which gives us a final slope of negative 1/4 if it's simplified. So great, we found the slope. The next thing that we want to do too is we want to put it into point slope form. Again, I'm going to write it one more time because I'm for achiever. Perfect. Right. Okay, so now we're going to plug information into point slope form to get our equation in slope-intercept form, because that's where we want to be. But first, we're going to start with this form and work our way there. So we have the slope, and then we have to pick a point. Now, which point do I use, and does it matter? Well, I'm going to do both and show you that it really doesn't matter. However, one of them is probably a smarter bet for us. So let's give this a try. So we're going to do y minus 2 equals, we're going to use that second point, and you'll see why this one might be slightly problematic in just a second, but it's not too bad. Either one works. X minus, so it'll be x plus 3 because we're subtracting a negative 3 there. Okay, so plugged in here, and then we can distribute that negative 1/4, which would be minus 1/4 x, and then negative 1/4 times 3 over 1. Negative times a positive is a negative. It'll be negative 3 over 4. Okay, so it's going to be minus 3 over 4. There we go. Now, it's still not in slope-intercept form, even though this looks like slope-intercept form, because it's not y on it. It doesn't say y equals on the left. It says y minus 2. We got to get rid of this minus 2 by adding 2 to both sides, which will give us y equals negative 1 over 4x plus, now this is $2 minus 75 cents, $2 minus 3/4, which is plus 1 and 1/4, or 1.25. So there we have our answer in slope-intercept form, and we kind of put that in there, and then we kind of had to solve was step 3. So we plugged things in, then we kind of had to solve and get things by itself. Now, you can get the exact same answer if you chose the other point. In fact, it's going to be maybe a little bit easier, you'll see. So if we choose the point 5, 0 to plug in instead, you end up with y minus 0 equals negative 1 over 4 times x minus 5. And so y minus 0 goes away, just y. And then you have negative 1/4, because we did the distributive property here. Distributing negative 1/4. Negative 1/4 x, and this is a negative times, negative times a negative, which is a positive. 5 over 1 times 1 over 4 is 5 over 4. But 5 over 4 is 1 and 1/4. So both of them get you the same answer. This is your last problem. You guys can try this one on your own. Pause the video, give it a shot, and check in just a second. Okay, let's do it. Slope first. Let's see here. It's going to be negative 1 minus 5 over 4 minus 1, which is negative 6 over 3, which is negative 2. Pick a point. Doesn't matter which one. I'll just use 1, 5. Y minus 5 equals negative 2 times x minus 1. So I'm plugging into point. So I did the slope first, plugged it into point slope form in step 2. And now we have to solve, which means we're going to distribute that negative 2. So you'll get y minus 5 equals negative 2x plus 2. Add 5 to both sides. So it should be y equals negative 2x plus 7. Y equals negative 2x. Whoops. Sweet. I'm going to make you watch me drink my sparkling water one more time. Hey, thanks for watching the video. Hope this was helpful. And yeah, guys, we'll see you next time.